graph specifically. So you need to support your result by using that graph. But if I cannot understand the result, even though that is perfect, so no other way. Okay? Do not try to use a very complex, looks like the sexy, nice graph. You can find the proper graph that can show your result the best one. Okay? So why don't you revise it, especially also when you write. So your method has something, the performance measure or the raw data and the feature. That's not the method, that's the evaluator. Okay, metric. The method is how predict, right? So that can be described. Then how to implement. So please revise your writing as well as the cursor. So then the misunderstanding. What is the slide show? Next. Yes. It's not coming out? Yes.
All right. Hello, everyone. My name is Scott. Brandon Ronaldo. Our project was based on predicting mortality. So the problem we're trying to solve is, depending on what certain variables that we chose, can we somewhat accurately predict the age that you are going to die. The data that we found was on Kaggle. The platforms that we used were Keras and TensorFlow, and majority of the project was cleaning the data because it was an extremely large data set. The years, it was millions of records from from like 1980 to 2015. So we narrowed that down to about 3 years. And the data was also from just from US. So. Yeah, I guess we'll go
Okay, so talking about the data, like Scott mentioned, it was a really large data set that we got from Kaggle. We got it from the CDC, which is basically like a repository for death information for this particular study. All the people that died in the United States in the last 10 years well, the one we used was from 2005 to 2015. So the data set consisted of about 70 different attributes, ranging from cause of death, age, sex, things of that nature, all the way to whether or not people were insured, type of insurance. There was some billing coding in there as well. So there was a lot of data cleaning going on initially to remove some of the redundancy. There was several different features.
Before that, did you guys use only the key feature, or that is just?
Yeah, so we'll get into that stuff right now. So the key attributes that we focused on heavily were these 7. This was kind of a lot of trial and error. At first, we just tried passing the whole data set through, which didn't work very well. It yielded some pretty bad results.
How did you guys decide the key attributes?
So that was as a result of trial and error. Right?
Okay.
So after passing the data through several times and then trying to manually clean the data, realizing that principal component analysis really wasn't helping us all that much, we went back and took a look at the actual data structure in some of the organization to try to understand why it wasn't really helping us. So after—
What about the covariance analysis? Did you use the covariance with the ground truth?
We didn't try using that.
That's one of the typical approach to decide the key feature. If you have the reliable ground truth, like if you have the aging, the death age, so you can compare. If you can find the similar covariance, with the ground truth, you can select such a feature as the key feature.
Okay.
Go ahead.
That's definitely some future work we could try doing. Yeah, so after some of the data cleaning and the trial and error passing through, those were the main ones we ended up focusing on for like our last optimization process after we actually got the model to work correctly. So, like I said, we removed some of the redundant attributes and the irrelevant data. Things like autopsy results, they were already like dead and we had diagnosis, so we didn't think that that would really be relevant. Also, a really important thing to note, we separated the data into training and test sets. So our training data was fairly massive. It was the 2005 to 2007 data set, which is like, it's like two or
It's a
3
million per every year.
Yeah, it's about 1 million cases per year. So
So it was like 3 million just for like the training set.
So you separate by year?
Yes.
So,
yes,
okay.
yes. So for our test data, we used the 2008 data set, which is kind of what all of our performance, ultimate performance parameters were based on. So you can actually go back to that one. I think there was still some stuff to talk about. Yeah, so ultimately we ended up reducing the dimensionality from 70 attributes from like the primary unclean data set down to 7. And one of the major things that we gleaned from doing that was removing, there was a whole bunch of different diagnoses, right? Each person who died had maybe 10 different diagnoses. There was a primary one, then a secondary, tertiary, all the way down the line. So what we figured out was that removing secondary, tertiary, et cetera, diagnoses yielded really good results. And I think one of the reasons for that was a bunch of people had kind of the same diagnosis. So what we were basically doing was taking a set of probably very diverse data and then non-diversifying it by saying a whole bunch of people from different age ranges had the same diagnosis, which obviously would make it very difficult to, make it a bad attribute to use for prediction. And ultimately our performance parameters were the accuracy, so our precision and recall were the age range of death versus our parameters in question. So we use the neural network to do all this stuff. Probably should have mentioned that earlier, but yeah, we use the neural network to train and then use as a predictor. So for this, we used Keras with the TensorFlow backend as our model.
It's a fully connected layer.
Yes.
Neural network, fully connected. And how many hidden layers?
We only just use one hidden layer.
One?
With, we experimented with like the number of nodes.
A number of nodes.
But we settled with like 100 because I think that yielded the best
Mhm.
result.
Because you guys already reduced the number of features, the dimension, it may work. But otherwise, so if you keep the original, and then you may think about the more complex neural networks.
Okay. Yeah, so like Ronaldo said, this was kind of a lot of training, trial and error. So we ended up with 100 neurons in our hidden layer and 11 neurons in the final layer because we had 11 different classes basically, which were the age ranges of death that we were trying to predict. So we settled on 10 epochs. We realized that using more didn't really give us a better precision or accuracy for what we were doing, and ultimately went with, after we had gotten the model to work, this thing called an atom optimization algorithm, which kind of is like an extension of like stochastic gradient descent. So what it does is it gauges and changes your learning rate and your
It basically improved like our convergence rate to be faster. So like those 10 epochs were actually giving us like the maximum accuracy, minimizing the loss than if we were using some other optimization with like a bigger number of epochs.
So we also went with our final performance parameters as we used weighted averages for everything, because this was a multi-class issue. Using like a macro or a micro average for everything was not good because it kind of skewed everything by not weighing it against the size of the classes. So if you have a very small class or several very small classes in a set of a bunch of classes that you're trying to like classify with, your accuracy and your precision in your recall will kind of be skewed by those two because they don't weigh the size of the class against the accuracy. So if you have a small class with 0 precision in recall and a very large class with good precision in recall, it's not going to weigh the size of those classes, so the importance of the classes against your overall precision in recall. So that's the reasoning behind why we use those.
Okay, so after basically all these things, so these were some of our results. Like so this first column described like pretty much like our initial values when we first started. That's basically we were not doing any PCA here and just passing like the whole data. I think at this point on we had about 27 dimensions before the reduced 7 that we decided on. And these were like the values that we were getting for precision and for the recall, which were.
What's the meaning of weighted? It's not just the average.
It's basically, as he was saying, so we have 11 different age groups. And some age groups we have a lot of data for it, and some of them we have like just a small amount of data. So that's kind of like how the average works, the weighted average. So.
Did you evaluate by age group also?
Yes, so we actually have a confusion matrix that we use, and it breaks it down class by class what each average was.
And that would be interesting.
Yeah.
So separated like nine years apart in the age groups.
Well, we will get to that. So after this was with like no PCA, so we decided to just try to implement PCA, pass the data through it, and then from the result of the PCA, use that as the input to our neural network. It did a little bit better, but not that much. And this is when we decided, like, instead of using all those, because every row in our data had about 20 columns that were reserved for diagnosis codes. So we decided instead of using those, let's kind of aggregate everything. So instead of having different like primary diagnosis, secondary diagnosis, instead of having like, let's say if we had multiple types of cancer, just aggregate all those into just cancer and just use like one diagnosis column. So that actually yielded better results. This was one of like a better testing run, and where we.
Quick question: when you evaluate, did you decide exactly say what is the error margin to decide whether correct or not? Like a year plus minus year, or the plus minus month? What is the margin?
You mean when we evaluate that data?
Yes, when you evaluate. So, for example, exactly the 80 years old, but if you predict 79.
Yeah,
so
but so what we're doing is we're predicting into age groups. So the way that we divide our age group, we had like 11, so it was like under 1 year old, 1 to 4 years old, 5 to 14, and so
whether
on.
that belongs to that group or not.
Belongs to that
I think
group,
you'd better consider that how much you approximate the variance, like a month or the year. So even the 3-5 years may be acceptable, who knows? So you can put that allowance like the X value, then see the accuracy. Probably if you higher, the error margin will be higher. Then you can decide what is because for example, we don't expect the exactly same day. The prediction.
And that's why we had like the groups, because we were like, it was probably never.
The bracket is also possible, but if you make the variable, then that will cover the most of the general case. Okay.
And so this was like our best result, above 50%, which is better than guessing. But we're trying to think of like ways that we could improve. And looking further at the data, we found that the columns that were for diagnosis weren't just for, let's say, the columns didn't mean like the columns weren't reserved for one specific diagnosis. So it's like was like just one column that could have anything in it, which we figured that was messing with our data. So what we decided to do is restructure the data and use looking at all the diagnosis code in our data and put them as a separate column and kind of use that as, I guess, some sort of one hot vector. So if somebody has multiple diagnoses, it would just be 0 for everything else and then 1 for the columns that they actually have. So doing so actually increased our dimension by a bunch. So we have basically been doing so. We had like over 30,000 dimension because of all the different diagnoses that were available to us. And then we run into issues where we couldn't actually process all the data. Like it wouldn't fit in memory. So this is like a snippet of just like using it for training on 40,000 rows and then testing on 14,000 rows. And just after modifying, reformatting the data and just this small number of sample, we were still able to get around above 50% accuracy. So we believe that like in future works, like a better method would be to change all the data into that format and use like maybe a relational database to be able to lazy load the data so we don't have to fit all of it in memory and do our training that way, and we believe that will actually increase our accuracy way better than our last result. So yeah, pretty much in conclusion.
Okay, so that's it. So what about your demo? Or do you have anything?
So it takes, as I was saying, we have so much, it takes forever to load. So I cannot just run it right now, but these are like, it's not even showing anything.
Okay, while you are preparing that, so my suggestion is first one is why don't you add more information about your optimized neural network, like so you can show so for example if you have the one hidden layer with the 10 neuron and the node, and you can draw the diagram and how you set up the initial weight, because somebody may be interested later to use your network if they satisfy with your and that is also you spend probably a lot of time to optimize, right? To find it's trial and error and so on. You should keep record. So then for future use, somebody may get the benefit of your testing and so on. So more details about what is the setup of your neural network and what value. Sometimes you can put the evaluate. You can set aside further evaluation to how to optimize the neural network for better accuracy and so on. So why don't you put more information about that's the value of the implementation. Second thing is, as I suggest, when you evaluate instead of a bracket can be, but what if because of one day, the January 1st, so it cannot be part of the previous, it's not much different, so you can use evaluate. It doesn't change your neural network, but it may consider for your, I'm not sure whether in your implementation you guys can consider instead of class bracket. Yeah, so that is the reason a lot of time instead of using the existing library, the in-house coding may be useful. You can save time for the research purpose and so on. So take a look at whether you are able to evaluate based on that error margin. Okay. Yeah. Then if possible, that may be very interesting also. Okay, thanks so much. And also I think this one definitely used for the life insurance. Definitely, they need such information because that directly related to their money. Yeah. So when you are going to die, so okay, thank you.